In this lab, the alcohol classification will make an attempt to classify alcohols as primary, secondary, or tertiary and compare the oxidation of those chemicals. So the classification of alcohols can be based on the location of hydroxyl group in relation to the hydrocarbon chain of the alcohol. So alcohol carbon is the carbon to which the hydroxyl group is attached. Primary alcohol, in primary alcohol, alcohol carbon bonds to just one other carbon. In the secondary alcohol, alcohol carbon bonds to two other carbons. And in the tertiary alcohol, alcohol carbon bonds to three other carbons. So different classes of alcohols oxidize, forming different products. Oxidation is the loss of electrons, or gain of oxygen, or loss of hydrogen. So primary alcohols, when they are oxidized, turn into aldehydes and oxidize further to carboxylic acids. Secondary alcohols oxidize into ketones. Ketones do not oxidize further. Tertiary alcohols do not oxidize. So in this case, aldehydes and ketones contain carbonyl group. So aldehydes have at least one hydrogen attached to the carbonyl group. Ketones have only carbons attached to the carbonyl group. So we're going to be using two testing systems. One is based on oxidation of primary and secondary alcohols by potassium permanganate. Tertiary alcohols cannot be oxidized. Lucas test distinguishes between primary, secondary, and tertiary alcohols by the formation of white insoluble layer. Primary alcohols do not react in the Lucas test. Secondary alcohols react slowly and may require heating, while the tertiary alcohols react rapidly, giving white insoluble layer. Now, in our first part of the experiment, I'm going to be adding different alcohols, 1-butanol, 2-butanol, 2-methyl, 2-propanol, and the unknown alcohol to 4 tubes that contain potassium permanganate. So each tube contains 2 milliliters of potassium permanganate. So I add 2 drops in the tube 1, 2 drops of 2-butanol into tube 2, 2 drops of 2-methyl 2-propanol in the tube 3, and 2 drops of unknown in the tube 4. And now I start mixing this tube. So that's tube 1. This is tube 2. This is tube 3. Now let's compare this. I don't see any difference. Well, we're going to try and add some more alcohol to these tubes. This is tube 4. Add some more. alcohol and see what happens. So now we're going to wait for the results. Now here in the first row I have 4 test tubes with all 4 alcohols, and now I'm going to add 1 milliliter of Lucas reagent and check for cloudiness. So we can immediately see that in the tube number 3 we see the cloudy appearance. So it's a tertiary alcohol, 2-methyl 2-propanol. Now we're going to wait some time, and then we're going to check for cloudiness again, and then we're going to heat tubes that are clear for 15 minutes in a water bath. In the meantime, let's take a look at our results with potassium permanganate. There is change between, you can see the difference between the primary and the tertiary. You can see a profound difference between secondary and the tertiary. Now this is our unknown, so let's take a look. It's definitely not tertiary. Okay, so that's tertiary alcohol, that's unknown, so it's not tertiary. So it's either primary or secondary. So let's compare them all 3. Okay. It's a little bit hard. It looks like primary, but we need to confirm it even further. Okay, so you see that color-wise it looks more like a primary. Color-wise it looks more like a primary. Primary, unknown, secondary. This is the tertiary alcohol, obviously very, very cloudy. This is the secondary alcohol. After 15 minutes of heating at 60 degrees Celsius, you can see that it's cloudy. It slowly becomes more and more cloudy. And the primary alcohol and unknown, they remain clear. So basically here and here there's no reaction. So our unknown is, it appears to be a primary alcohol. You should draw the structures of these chemicals. You can find it, Google it. You can figure it out. You determine if it's primary, secondary, or tertiary. I kind of gave it away. Our experimental results, well, it's up to you to judge whether they agree with our classification. And then you should classify following alcohols as primary, secondary, or tertiary based on the structure. So an oxidation of an alcohol involves the removal of or an addition of here. The answer is here.